All right, so we'll go through naming of ligands. So how do we name ligands? Okay, so from there, then we'll also talk about other things. So it will be a very short video. So let's just pay attention to what I'll be saying, okay, than to what I'll be lighting. So what we need to know is that, all right, so we need to understand one thing, all right. So we are talking about ligands, of course. All right, so we are talking about ligands in general. So what is this ligand we are talking about? All right, so we'll say a ligand. So a ligand is just a molecule or ion which bound to a central metal ion or atom. All right, so it will bound to a central. Suppose this is a metal. All right, a ligand will bind like that. Let's say this is fluorine. All right, okay, so this fluorine is now a what? A ligand. So a ligand is just an ion or a molecule that bound to a central metal ion or an atom or just atom. All right, so this metal might be an atom just in general um or ion. Okay, so now what you are going to do is we'll actually list some of the common ligands that we've been using when naming complex compound, all right, or coordination compound. So what we do is suppose you are given um suppose you are given okay, suppose you are given OH like that. All right, we know this is hydroxyl, but it has a charge of what? -1. -1 like that. So after this, how do we call it then? What is the name? So when you see a ligand like this, so we call this as hydroxo. All right, so you call it as hydroxo. Okay, so that is the first ligand you have. So the second one, let's say suppose we are given um um O2 like that. Okay, like that. So this is having a -1 charge. So how do you call this one? How do you call this one? So we'll call this one as super. All right. So it's more like a super because there are two atoms of oxygen. So super oxo. All right. So if it was just a single like that, if I were to write like ox like with a negative there, it will have a negative what? 2 charge. Then this will be just the oxo. All right. But by the virtue of having 2 there as diatomic molecule, then we'll write as what? Super. It's more like a super is a bit stable than the oxo. So that is it. So we'll know how to use even when naming coordination compounds, but let's go to a next molecule. Suppose we are given SO3 like that, okay? So with a charge of 2 negative there, the charge will be -2. So that's a charge there. So let me write like that, Q as charge to represent charge. So what we say now is, suppose we're given like that molecule. So that molecule will be called SAU. Of course, it's sulfate like that, sulfate, something like sulfate. But how do we finish it up? All right. So this will be just the sulfito. Okay, sulfito like that. Then let's say we are given now this a carbonate. All right. So a carbonate will be there like that. It has a charge of negative. So how do you call a carbonate when you see it as a ligand? So when naming, or you name that ligand as carbon from the word carbon. This is carbonate, right? Carbonate, carbonate. But in this case, it will be just carbonato. All right. So like that, as simple as that. So carbonato, carbonyl. We also talk about that. So let's say we have uh number 6. Let me give what can I give? Okay. So suppose we are given now sulfate, lead sulfate. This is sulfate, but this is it was sulfate, now it is sulfato. It was carbonate, is now carbonato. What about just the sulfate now? All right. So still having the negative charge of 2. So it was sulfate, it is now what? Sulfato. All right, so that's the trick part of this one. You always add O at the end. All right, sulfato like that. Then suppose we are given now, let's talk about halogens. Halogens, let's say we are given chlorine like that. Chlorine is always having a negative there, so it's a negative charge. So how do we call chlorine? Okay, this is the chlorine, but it will be just the chlorido, all right? Or chlorido, just chlorido. Okay. Okay, so that is it. Then let's say now we have fluorine, all right? So all these are halogen. Fluorine is charged with a negative there, so it has a negative charge of 1. So how do we call it as a ligand? So we'll call this as what? Fluorido, chlorido, bromido, iodido, something like that. That's how we name halogen elements or halogen ligands. So we'll call this as fluoro. All right. So it's fluoro. Okay. Florido. All right. Just like that. So that's how you name this guy. Then let's go to bromine. Suppose we are given now bromine. All right. Bromine, we know it is also a halogen element which will have a negative charge there. So how do we call it? We call it bromido. Bromide, from the word bromide, you add O at the end. Bromido. Fluoride, you add O at the end. Chloride, you add O at the end. Sulfate, you add O at the end of any number. Then carbonate, you add O. All right. Sulfate, it was supposed to be sulfate, but you remove that E and add O. Just the trick. That's the trick about these um compounds or molecule that we have. All right. So let's go and give iodine. So iodine, we call it iodine, right? Iodide. If it is a molecule, we call it iodide, right? With a negative charge there, being iodide, all right? Iodide, we remove this E at the end and we put O. So that would be iodido. All right. So it will be iodido, just like that. Then number 11, we can give something like, suppose we are given so the tricky part, let me give you this compound. I'm sure a lot of you knows this compound. So it's easy uh, with 2 oxygen there. All right. So meaning it has a negative 1. How do you call this one? This compound. So this is what we call acetate. All right. Acetate. So the compound is acetate. Acetate, right? So instead of calling acetate, we'll call it acetato. So you just remove, the trick is just to remove the E at the end or N letter at the end. So it will be acetato like that. All right. So that is it about these ones. So let's talk about now. Suppose you are given, so we'll continue. This is now will be 12. All right. Then we'll have a ligand there, then we'll have a charge, then a name there. Okay, so this ligand that I'll give you, we know this is what? This nitrate or nitrate, right? So nitrate has a negative of what? 1. So what will be the name of nitrate as a group? So nitrate can be bonded to oxygen at this point, because when you light it, you can light it in the form of nitrate like that. Okay, so it can either bond to this nitrogen or it can bond to oxygen. So they both have some pairs of electrons. All right. Okay, so that is it for nitrogen. So when it is bonded um to this nitrate, when it is bonded through nitrogen, then it will be, let me put this to mean it is bonded through nitrogen. Then when it is through nitrogen, you can call it nitro, nitrito, nitro, you can just call it nitro. All right, nitro, or you can call it as nitrito N. All right. So to mean just you have used the bond of N. Okay. So nitrito N to mean it has been bonded to nitrogen. All right. So the same case, if it is now bonded to oxygen, we'll call it. All right. So it has a negative one. When it is bonded through oxygen, when it is bonded through oxygen now, how are we going to call it? All right. So it will be called nitrito. By the way, when it is nitrito, it is through oxygen. But when it is just nitro, all right. So I'll call this is it was just nitro at this point. So now I'll call it nitrito. All right. Once I call it nitrito, then I can also call it as nitrito O. All right. So to mean it has been bonded to, so I can just be calling it nitrito O, nitrito N to mean that's a bond instead of using nitro and nitrito. All right. To mean where nitrogen and oxygen are bonded respectively. So what we can also say is that suppose you are given now um, that was nitrate, but let's say you are given nitrate. All right. So uh 3, then is still having a negative 1. So the charge is still 1. Then how do we call this one as well? So this will be called nitrato. All right, nitrato. So it's called nitrato. Nitrato like that. Okay. So you call it nitrato like that. So the other thing that we can also give is, let me give you this a neutral compound. Let me give you some neutral ligand. So we can have neutral ligand, those ones which do not have a charge or lone pair, so they do not have charge with them. Okay, so we call them neutral ligands. So let me give you one example or two. Then I can start with the well-known guys, which is the H2O. All right. So this H2O, it has a charge of 0, which is just neutral. Then what is the name? We call it aqua. All right. Aqua as the ligand. Okay. So that's a name for water. So let me give you another guy who is just neutral as a ligand. So I'll give you the guy known as amine. All right. Okay, amine. So it is also, it doesn't have a charge amine. It has just those lone pairs. Then if we were to present as a ligand, it has just those lone pairs and the charge is 0. So how do we call amine? All right, it's just your amine like that. By the way, I'm supposed to use a capital letter there. You always start with a capital letter. These are names of someone. Consider molecules as just living things as well. All right. So it's called amine, but when it is in a chemical bond, we'll remove one N. You'll see how we'll be demonstrating that. Okay. So but let me give you another neutral ligand that can be let me just give you methylamine. We know methylamine as N. Amine, it is this, right? With the 2 there is an amine. All right. Okay. So then a methyl, you can put a methyl there. All right. So a methyl there, this guy is also doesn't have the charge because of this amine which is there. It has only lone pairs like that. So we'll call it just ethylamine, okay? Or amine ethyl, but we normally call it methylamine. Methylamine like that. So see, it is now in a bond, so I will not include the other M. So I'll just write like that. So when it was just alone ammonia, it was now amine. Now that it is in a molecule, another molecule is forming a big molecule. So we'll call it as just amine with a single M. All right. So those are some of the neutral ligand that we can have, and it's important that we get to understand, to master just these 3. These are enough, like methylamine, amine, just aqua, which is water. All right. So I can also give another one, which is carbonyl. So carbonyl, I'll write it as CO, then O, all right? So then we call it carbonyl, all right? Carbon monoxide is called carbonyl, all right, as a ligand. Okay. So then what about hydrogen? Hydrogen will have a positive charge one sometimes it can behave as a neutral. So I'll say this is just hydrogen, but we said we remove for these gases hydrogen, it will be now hydrido to mean as a ligand. So hydrogen to be hydrido. All right. So that is about for hydrogen. So it can behave as a neutral, sometimes as a positive. So just call it hydrido and put a charge of that. All right. So the other thing that I can give you is the what about nitrogen monoxide? So nitrogen monoxide to look like this. All right. So this is nitrogen monoxide. Um is also this is an ion ligand. So I'll put a negative because of this oxygen which is here. It will donate some electrons, and you have been seeing how oxygen and nitrogen behave when they are making a bond. So I'll call this nitrogen as nitrosyl, just nitrosyl, because it was nitrate in the beginning. Remember, now it will be called nitrosyl. So not really important. Let me put the last one, 20. So we'll put some kind of E. So there's a compound we call it E, all right? So this E, or I can call it as En, all right, to mean let me just have some space with me. Okay, so there's this also ligand. Sometimes we normally abbreviate as En like that, okay, to mean ethane diamine. So this will look as follow. So the structure will be we just have two ethane, all right, two methane and also two amine, all right, amine group. So put amine group there, all right. So you can put the two there and also the two there, or if you want you can write as amine, all right, which is just the methyl there with two, all right, methyl, again we have a methyl there, so we put amine, again we put amine like that. Okay, so this is amine. So by this, we can call this as what? A dentate, ambidentate ligand. So meaning that it can bound to a central metal with just two arrows. Okay, so it will use this guy and also this guy to bind at the metal. So ambidentate ligand, that's the name given to such, and they will make a chain like so, which is what we call a keratin. We call it a keratin when they are making a chain like that. So as for now, know this as we have two amine and two ethyl. So I'm methyl. So we call it two methyl. They are known as what? Ethyl, right? Then amine. So we just mentioned to say we have at position one, we have one amine. Again, if we were to count one, two, again at position two, we have what? Two amine, which is this one. So we'll call it two ethyl 1,2 di, because there are two diamine. Okay, so that is it about this. You name them like this. Let's give these ones the common one. Let me just give you the common one again. All right. So suppose for cyanide, so cyanide we have negative like that. So it is charged with a negative cyanide. So we call it cyano. So as a group, we call it cyanide. All right. So what if now we have um, um So when it is bonded to N, so this when it is bonded to C is called cyano. What if it is bonded to N? All right. So a central metal will be now bonded to N, and what will be the charge? I mean, the charge is still -1 because we can see through nitrogen bond, and we call it isocyano. So wherever N is involved in the bond, use the word iso. All right. So this is isocyano. Okay, so that is about this. Then let's go to these ones which are just important as well. So sulfur cyano, let's say we have through sulfur, all right. Then we have C there, then N like that. So through sulfur, let's say it's bonded through sulfur. I said when S is involved and also N is involved. Let me do this again. When again we have N, S, again the metal is now bonded to N. So how do we call that? Of course, there will be always a negative charge. There will be always a negative charge like that. But when it is N, always when it is N, put iso. All right. But since there's some kind of sulfur, so we call it thio. All right. For this case, it will be thiocyanate. So it's what? Um, thiocyanate. Just like that. This is when now it is in a molecule. All right. Thiocyanate. But when it is just alone, you call it thiocyanito. Just like that. So this is now like it is bonded. Assume it is now bonded to a central metal. Also here it's bonded. So when it is N is involved in the bond, we call it isothiocyanate. All right. So these are some of the ligands that actually we'll be dealing with in the naming of coordination compounds, and it's important that you get to master one or two, especially for the case of thiocyanate and also isothianate. Also know ethyl-diamine, and also some other things like bromine, fluorido, iodido, and also acetato, and also even aquaamine, those carbonyls, they are very important. And also when nitrogen is involved in the nitrate, we call it nitrito N. When oxygen involved in nitrito O, just like that, then you continue with your naming. So it will be very important that you master one or two things, especially those that you have been seeing in past papers. So go and practice, write them down somewhere, then it will be very important. It will be of use if one day.